The battery sitting in your car right now is probably not dead. It thinks it is. Your mechanic thinks it is. The AutoZone diagnostic machine thinks it is. But the actual chemistry inside that battery is almost certainly still functional. And the proof of that is a white crystalline powder that costs $2, dissolves in water, and reverses the specific chemical process that kills 80% of all car batteries before their time. The automotive battery industry generates $45 billion a year globally. The average replacement battery costs between $150 and $220 at any shop. And the average driver replaces theirs every 3 to 4 years like clockwork, because that's what everyone does, because that's what they were told to do. Here's the number that should stop you cold. A study published by the Battery Council International found that up to 80% of batteries returned as dead under warranty still had recoverable cells. 80%. They weren't dead. They were sulfated. And sulfation is a reversible chemical process that the industry has known how to fix for over 60 years. The fix costs $2. The replacement costs $200. Stay with me. But before I show you the restoration protocol, you need to understand how we got tricked in the first place, because this isn't a coincidence. This is design. Here's a short history lesson that explains your last 3 battery purchases. The lead acid battery was invented in 1859 by a French physicist named Gaston Planté. The core chemistry has not fundamentally changed in 165 years. Lead plates, sulfuric acid electrolyte, and a reversible electrochemical reaction that stores and releases current. That's the whole machine. For the first several decades of the automobile era, batteries were serviced. Gas stations had battery service bays. Mechanics topped off electrolyte fluid. They desulfated plates with controlled charging cycles. A well-maintained battery lasted 8 to 10 years. That was the standard. Then in the 1970s and 1980s, 2 things happened simultaneously. Battery manufacturers introduced the maintenance-free sealed battery, and the automotive service industry quietly stopped training mechanics in battery restoration. The sealed design was marketed as a technological upgrade, easier for the consumer. No messy fluids to check, no service required. What they didn't tell you is that maintenance-free was never an engineering term. It was a marketing term. It means maintenance is no longer your option. The battery sealed itself in a condition that guarantees a replacement purchase every few years. Because the one thing a sealed battery cannot escape is sulfation, and they knew that. Here's what sulfation actually is. Every time your battery discharges, lead sulfate crystals form on the internal lead plates as a natural byproduct of the reaction. When you recharge, those crystals are supposed to dissolve back into the electrolyte solution. That's the cycle. That's the design. But if the battery sits partially discharged, if it's repeatedly undercharged by a weak alternator, or if it runs in extreme heat or cold, those lead sulfate crystals harden. They calcify on the plate surface. They stop dissolving. They coat the plates and reduce the surface area available for the chemical reaction. The battery loses capacity, loses cranking power, and eventually stops holding a charge entirely. Your mechanic hooks up a diagnostic reader. It reads low voltage. He says the battery is dead. You pay $200, but the plates are still there. The case is still intact. The electrolyte is still conducting. The only thing wrong is a layer of hardened crystals on a lead surface. That's not a dead battery, that's a dirty battery. And chemistry doesn't care what your mechanic charges per hour. The actual process of restoring a sulfated battery requires one thing: a chemical compound that dissolves lead sulfate crystals without damaging the lead plates underneath. And that compound exists. It's cheap. It's sitting on a pharmacy shelf right now, and the industry has known about it since before your parents were born. Let me tell you exactly what to buy and where to find it. The first thing you need is Epsom salt. The brand doesn't matter. You'll find it in the pharmacy aisle of any Walmart, CVS, or Walgreens. A 1-pound bag runs about $2 to $3. This is magnesium sulfate. And when dissolved in distilled water and introduced into a sulfated battery cell, the magnesium ions help break down and suspend the hardened lead sulfate crystals that are coating your plates. The mechanism is ion displacement. The magnesium competes with the lead at the crystal surface and disrupts the crystalline bond structure. It won't eat your plates. It targets the sulfate deposit specifically because sulfate ions have a stronger chemical affinity for magnesium in solution than they do for lead in crystalline form. That's not folk chemistry. That's basic inorganic ion chemistry. The physics don't negotiate. The second thing you need is distilled water. Not tap water, not filtered water. Distilled, the kind sold in 1-gallon jugs at every grocery store for about $1.50. Tap water contains dissolved minerals, chlorine, and trace metals. Introduce those into a battery cell and you add contamination that accelerates plate corrosion. Distilled water is chemically neutral. It carries nothing in, and that's exactly what you want. That's it. 2 ingredients, total cost under $5. and you'll have enough Epsom salt left over to do this 3 or 4 more times. The third thing you'll need isn't a chemical, it's a tool. A battery charger with a slow charge or trickle charge setting, the kind sold at AutoZone or Walmart under brands like Battery Tender or Schumacher. A basic model runs $25 to $40 and you'll use it for years. If you already own one, your total material cost for this restoration is under $5. Now, one important note before the protocol. This process works on flooded lead-acid batteries and most standard automotive batteries, the ones with removable cell caps on the top. You can identify them by the row of plastic caps, usually 6 of them, running along the top of the case. Those caps unscrew. That accesses everything. If your battery is a sealed AGM, which stands for absorbent glass mat, or a gel cell battery, this specific protocol does not apply. GM batteries have a different internal construction, and the electrolyte is not a free liquid. You'll know it's AGM if the label says AGM VRLA, or if there are no removable caps on top. Check before you start. For the 70% of standard vehicles running flooded lead-acid batteries, which is the majority of cars on the road, this is your fix. Here is the exact process. Follow the sequence. The sequence matters. Start by removing the battery from the vehicle. Disconnect the negative terminal first, always negative first, then positive. Lift the battery out and set it on a flat surface in a ventilated area. A garage floor works. Outside works better. Batteries off-gas hydrogen during charging. You want airflow. Now take a close look at the top of the battery. You'll see the 6 plastic caps in a row. Some are individual. Some are covered by a single plastic strip you pry off. Use a flathead screwdriver to pop them open. Set the caps aside and don't lose them. Shine a flashlight into each cell. A healthy cell has electrolyte fluid covering the lead plates by at least 1/4 inch. A depleted cell will show plates that are partially or fully exposed. You may also see gray or white crust on the plates. That's crystallized sulfate. That's exactly what we're treating. Now mix your solution. Dissolve 1 tablespoon of Epsom salt into 1 cup of warm, distilled water. Stir until fully dissolved and the water runs clear. This is your restoration fluid. Using a turkey baster, a syringe, or any clean dropper, add the solution slowly to each cell. You're looking to bring the electrolyte level up to just above the top of the plates, about 1/4 inch of coverage. Don't overfill. If the cell already has adequate fluid level, add only a small amount, roughly a teaspoon, to introduce the magnesium sulfate into the existing electrolyte. Work through all 6 cells evenly. Replace the caps loosely. Don't seal them completely yet. Gas needs to escape during the charge cycle. Now connect your battery charger and set it to the lowest possible charge rate, 2 amps if that's an option. Slow charge only. This is the step most people get wrong, and it's the most important one. Here's the insider rule that makes this work or fail. Do not fast charge. A fast charge, 10 amps or higher, will heat the electrolyte, cause the Epsom salt solution to react too aggressively, and can warp the lead plates you're trying to save. A slow 2 amp charge over 24 to 36 hours gives the magnesium ions time to work gradually on the sulfate crystals, while the charge cycle simultaneously helps break them back into solution through the natural electrochemical reaction. The combination of slow charge plus magnesium sulfate is what does the work. One without the other is significantly less effective. Let it charge for a full 24 hours minimum. For heavily sulfated batteries, 36 to 48 hours at low amperage gives better results. After the charge cycle completes, let the battery rest for 2 hours at room temperature. Then reinstall it in your vehicle and test it. If the engine cranks normally, you're done. Now here's the honest timeline. A mildly sulfated battery, one that's been sitting discharged for a few weeks, responds within 1 full charge cycle. You'll notice the difference immediately on startup. A moderately sulfated battery, one that's been underperforming for several months, may require 2 full charge cycles with the Epsom salt solution to show full recovery. A severely sulfated battery, one that's been dead in a garage for a year or more, has a lower success rate. Roughly 50 to 60% of those recover fully. The rest have plates that are too far gone. But even at 50%, a $5 attempt before a $200 replacement is math that makes itself. Not instant, but in most cases permanent. You might be wondering, will putting Epsom salt into a battery cause damage? Will it corrode the terminals, eat the plates, or cause something worse? Here's what science actually says. Magnesium sulfate is chemically inert toward lead. It does not react with the lead plates, the lead terminals, or the polypropylene battery case. The interaction is specifically between the magnesium ions and the crystallized lead sulfate deposits. That selectivity is the reason this works without causing collateral damage. The actual danger to your battery is the opposite of what you're doing here. It's the chronic undercharging and sitting at partial discharge that degrades and eventually destroys batteries, not restoration attempts. The manufacturer's own battery maintenance guidelines, published by groups like the Battery Council International and referenced by the Society of Automotive Engineers, have long acknowledged that sulfation through improper charge maintenance is the leading cause of early battery failure. The Interstate Battery Technical Documentation, which is publicly available, states directly that sulfation accounts for the majority of battery failures in vehicles under 5 years old, not age, not physical damage, sulfation from improper maintenance, a problem they know is chemically reversible, a problem that a $2 compound addresses, a problem that generates $45 billion in replacement sales annually, and one safety note that belongs here. Sulfuric acid electrolyte is corrosive. When you open the cell caps and work with the fluid, wear safety glasses and gloves. If any electrolyte contacts your skin, rinse immediately with water for 15 minutes. Work in a ventilated space and keep open flame away from the battery during charging. Hydrogen gas off gases during the charge cycle. These are standard precautions, not emergencies, but they belong in this conversation. The actual chemistry you're adding, magnesium sulfate dissolved in distilled water, is food safe. It's used in agriculture, food processing, and medical applications. It's not the hazard. The existing battery acid is the hazard. Treat it accordingly, and the process is completely manageable for anyone who can change a tire. Let's look at the numbers one more time. The global automotive battery replacement market is worth $45 billion annually. The average American driver spends $150 to $220 on a replacement battery every 3 to 4 years. Over a 30-year driving life, that's somewhere between $1,200 and $2,000 in battery replacements alone. Per driver, a 1-pound bag of Epsom salt, $2, a gallon of distilled water, $1.50, a slow trickle charger you own once and use forever, $30, total investment to restore a battery that your mechanic called dead, under $35, and the Epsom salt restores 4 more batteries after this one. A $150 replacement battery that permanently solves the problem a customer is paying $200 to repeat every 3 years is not a business model. It's a business ending. The sulfation cycle is the product. Your battery degrades, you replace it, a new battery starts degrading, you replace that one too. The maintenance knowledge that could break that cycle was quietly removed from the service industry decades ago. It didn't disappear, it just stopped being taught. You now know what a $45 billion industry is counting on you not knowing. The next time your mechanic runs a diagnostic and tells you the battery is shot, you'll know to ask one question first. Is it sulfated? Because if it is, you've got a $2 fix sitting in the pharmacy aisle and 36 hours between you and a fully restored battery. If this saves you money, hit the like button. It tells the algorithm to show this video to other people getting handed a $200 bill for a $2 problem. And if you want the next material science trick that exposes an even bigger household markup, the video on your screen right now shows you exactly that. Take care, and I'll see you in the next one.